Okay, so we're going to go ahead and begin the roundtable discussion. Can I get the last couple of speakers to find seats at the table with the microphone? Come on, come join us. We want to be inclusive. Okay, so the topic of this roundtable, which I think all of our speakers today led into quite well, is what is the future of multimodal neuroimaging? And in particular, where do we hope to be in 1 year or 5 years? What do we need to do to get to those points? And if I was to endeavor to try to do this in either 1 year or 5 years, what would you hope to be able to talk about at that point? Anyone want to kick that off?
Well, let me start with something that might sound a little bit grumpy. but multimodal imaging requires knowing a lot of skills, but not necessarily knowing the skills, but having the equipment, having it calibrated, having it working properly, and having people around that can keep it working properly. And so I think in order for us to engage in the scientific advantages of multimodal images, we need to think seriously about the structure for multimodal imaging, including training and actual equipment. I'll stop.
I'll continue the grumpiness from yesterday. No, I'm not going to be as grumpy as yesterday. I just want to make a plea for, if we are going to do multimodal imaging, which I think is incredibly worthwhile, and it's so difficult and technologically intricate, as Joy just said, that we really seriously think about the kinds of experiments we put through that mill, that we have really good reasons for doing that, and we think through our experimental designs really carefully and really make sure we've got all of those, the experimental controls that we need to answer the scientific question definitively, rather than sort of ending up with sort of a maybe kind of answers to the question. And I think we don't pay enough attention to experimental detail and experimental design, and I think it's time to do that again. I'll stop the grumpiness now.
So I agree. I agree that we don't spend enough time looking at experimental design. I also think that, as came out several places during several talks here, is that we have an expectation and we don't iterate enough between looking more and more deeply at the subtle aspects of the data and the relationships. I mean, there might be, a clear agreement or a clear disagreement, but if you look more carefully at the dynamics or latencies or spatial locations or patterns, you might find differences, and then things become interesting in that regard. So I think more of that should happen as well. I also think that if you, and I'll be talking a little bit about this at the very end, but just very briefly, if you have a whole matrix of all your modalities that you could possibly do, I think it's important, I think it would be useful as a community to think carefully about which modalities are complementary and what are not and what are overlapping, and how can it be more synergistic rather than just more data. So
yeah, I think just to sort of build on that, I've been learning more and more about intensive repeated measures experiments, so longitudinal experiments that acquire data from people many times throughout the day using EMA, for example. And I've been thinking about how what it would be wonderful to do is to have imaging biomarkers that are able to predict the variation day to day of some of these mood symptoms, cognitive variations, et cetera, because there is some evidence that those day-to-day variations are more relevant for the state of the disease or the disorder than a single shot measurement is. But our multimodal data will most likely remain single shot, at least the majority of it, because it's so expensive, because it's hard for the person, et cetera. So what I'm wondering is whether there's an opportunity for multimodal imaging to be the predictor of that variability, the day-to-day variability. It's one way to think about that concretely is to say, well, if we have underlying structural connectivity of a person and then we have the dynamics that occur on top of the structure, to the degree that these two diverge from one another, maybe that is a measure of how flexible dynamics is in general and would be predictive of day-to-day changes as well, which actually brings me to the reliability question too, because I think eventually what we're going to want is something that reliably predicts temporal variation, which seems challenging, but exciting too.
I think one of the things that I would say is I would hope that it's just more of a focus on methods for actually building the links between the modalities. And I mean, I think you saw some examples today, but I think that that's essential, you know. And the one other thing is, it's one thing to go between modalities, but even within modalities, there are so many measures, and, you know, there's not enough. Folks will often, you know, between some of the salami slicing you see, and just not asking the question of how can we reduce the range of features within a given modality, that would probably go a long way in facilitating multimodal analysis just by making it more tractable. But I think the analytic piece is the most essential piece right now.
Actually, I had a question for you, Mike. I was going to ask you after your talk about how you come down on the issue of whether data should be acquired simultaneously or sequentially. And do you see that as having any impact on your opinions about the reliability?
I would love for it to be simultaneous. With that said, I know we've spent the last year getting fMRI EEG simultaneous acquisition to be at a point where we could be happy with ourselves, and I still can't get folks to, you know, really believe that we're going to see that in large-scale studies. That's why I think that's where the movies, as an example, becomes interesting as far as a probe that you can repeat in different places, and you know you will have some variation associated with repetition and so forth. But there's also, you know, with some of the more poignant movies, one can make an argument that all those features will, and the brain's responses will remain. But that becomes a way of linking non-simultaneous acquisition. But I mean, simultaneous is always the more desirable. Now, on the flip side, if you step away from the MRI, that's where, when I was mentioning with McKeague's framework of having all these different measures simultaneous, and he's already built into EEG Lab the capabilities for linking them up, that becomes a very powerful platform to build from if it could be done effectively. But still, even with that, you do have significant setup costs and significant, you know, getting that data with high quality is not trivial. But I do think that's definitely a value.
Maybe also jumping on what you just said about that, new methods that we would need to combine all these modalities. And do you really think we need new machine learning methods or new techniques to predict, or basically things exist out of the box? I mean, you can stack linear models to combine modalities. We have so many existing stuff, and one of the difficulty I see is that if we have so many of these options and we don't really know what's the right thing to do, is because either they are not properly compared, or we have the error bars are too big that it's quite hard to know if one is really consistently better than the other. So you have all these techniques that exist, and I'm not sure, I mean, maybe I'm shooting myself in the foot writing papers myself about all these methods, but at the end of the day, maybe what we would need to really know if we have enough methods or enough on-the-shelf methods to predict is to have tasks on which we have enough samples, so the error bars are small, and we can truly conclude that this is the right thing to do. And I would have like some baseline techniques, typically stacking linear models, and I think that could be hard to beat. And I would say, do we really need more than this?
I think it's a very fair question. So I think there's a few answers. One is, and I think this is kind of where Danny was going, as far as you could try to come up with more biophysical models and understand the links from that perspective. That's one whole domain of work. And I think that is essential to really kind of figure out how the pieces fit together. On the flip side, if it's just a pure prediction question, one could argue, well, fine, I have this whole range of features from different modalities. I think the challenge there is, I mean, frankly, I think the problem is often, what are you trying to predict? If you look at it from the perspective of treatment response, that's a great one, but the problem is it's challenging to get large treatment response cohorts, and so that, I think, is a big setback for the field. There's longitudinal data, which the longitudinal data resources are building and will keep building in years to come. As far as predicting diagnosis, that there are certain trepidations associated with, just given the many questions inherent to DSM diagnosis and fit for biological research that need to be dealt with, but there's still value there. You need to deal with comorbidities and those style of questions. And then there's all the range of dimensional measures, which, self-report questionnaires can do pretty well with being reliable, but there's also limitations. I think the EMA is potentially more ecologically valid approach to go. The cognitive tasks, I think, really, I would not, I think the problem is, even if the imaging was perfect, I think so many efforts would fail, because it's all the phenotyping that needs an incredible amount of innovation. And I think as the imaging gets more developed in genetics and other fronts, because it's a common problem across everything, it does push on the need for innovation of phenotyping. I think the EMA, the sensors, these are the venues where I could, going more increasing presence of physiologic measures. I think those all have more hope.
Yeah, I think the other thing to add to that is what Robert was talking about yesterday, about being able to have integrated models for data analysis. And that's something that we don't really have up till now, but with one notable exception. I mean, Danny's work, the study that you showed today, showed how you can integrate data from multiple modalities, the genetics, and the structural information and so on, that you can and look at that in an integrated way. And I think that's what we need more of across the modalities. I don't think we need to acquire data with different. I don't think we need more methods to acquire data. We've got those. We've got the methods that have high spatial and high temporal resolution and so on, but we haven't really explored how to really optimize them and put them together.
Building onto some of this in sort of the last 5 years, next 5 years framework, I feel like if we went back 5 years, there was a lot of methods, people saying, here's some cool tool I made to integrate data, and a lot of scientists collecting multimodal data saying, hey, I have these two data sets, I'm going to sort of fudge together how to analyze together to get something uniquely useful. And as was shown a lot during this workshop, there's the growing amount of research where those are really combined, where you're getting people asking questions, knowing what tools could exist or potentially exist. And I suspect that's going to be the big jump in the next 5 years, that a lot more people will be asking questions, knowing what's possible, than has been true in the recent past even. And that'll hopefully become a lot more useful studies, because the methods development without the questions obviously isn't going far.
I'll echo one point that I brought up yesterday that was also brought up online just now, which is the value of behavioral research and neuropsych assessment and making sure that we do get complete pictures. But I think there's also something that has been understudied at this point, which is the value added of neuroimaging to go beyond what neuropsych tests can give us. And an example of this is, in my own field, in terms of reading disabilities, is that when you bring in a child who has a reading disability, we'll put them into some kind of treatment, but we can't tell you if that treatment is going to work. Pretty much random. And so about 30% respond to the first one, doesn't work, we put them in a second one, doesn't work for 30% of those, put them into a third one, so on and so forth. But there is some encouraging research coming out of Robin Morris's lab at Georgia State, where they've used DTI tractography along with resting state networks to identify which children will actually respond and which children won't respond to a reading intervention. And what's phenomenal about this is that that's information that we can't get from a neuropsych assessment in the first place. So there is likely a combination of these behavioral measures to identify problems, because honestly, no one's necessarily asking you to put someone in the scanner and tell them if they have a reading disability. I can do that with 5 cents of photocopies. But there are plenty of times where we can say, oh, you've got a familial history of, say, schizophrenia or major depression, something like that. And how can we sort of use imaging to get at things that neuropsych testing can't get?
Just to follow on from that, I think getting richer measures of behaviour are what we need. I mean, I think the days of just simple button presses and 2, forced alternative choice tasks. They're very useful for some things, but I don't think they're used so much, and I'm guilty of that too. But I think what you were just saying, Peter, about richer measures of behaviour, having people speak and examining spontaneous speech or things like that, richer measures of behaviour, and that I think could be better related to the imaging findings. And then I think things would be more meaningful and make more sense.
If you guys accept questions from outside the group, then anyway, if you're accepting questions from outside the group, then I'll ask everyone together. With relation to the questions of better characterization of behavioral data, what do you see the role of case studies and small unique populations, which are very, very well characterized, what people are calling deep data, in this upcoming era of big data and multimodal acquisitions and so forth?
I'll take a stab at that one. I think that is, and this is how I've always used case studies. I inhale those case studies because I use those for future ideas for my future science, and they always provoke interesting scientific questions, some of which have immediate answers and some that don't. And I think that they've always seeded my work. I've always relied on the studies of Penfield and the like to inform my research. And I hope to be able to be reading about case studies like that in the future.
Yeah, I agree. I think just like Michael was saying when he was answering my question before, I think there's a whole continuum. There's case studies that sort of point the way to maybe something intriguing and maybe something illustrative. There's N of 10 studies that point the way a little bit more, N of 100, whatever, and then, the big data that finally potentially gets at some sort of biomarker or something like that. But yeah, no, I think actually those case studies are really intriguing for sort of, aiming your direction to go, that sort of thing, or maybe providing a little glimpse of insight into a direction to go. But, yeah.
Can I go in a very different direction? Yeah. Okay. So something that I saw today that I really like is we were talking about making, I'd like to see in 5 years we don't talk about rest, because I don't think it exists, and I think anything that we can do to understand like all of these measures that we're talking about, it becomes then something you can compare against and test in a deep data set or a big data set. So I like that in general. I think also with a deep data set, we maybe have the ability to look more at how not only do the methods work really well together and what we can capitalize on, but also we may not talk enough about how the methods don't work and can't be compared. So maybe people can help me understand what's out there, but we have best practices for talking about methods within each modality. Do we have best practices for talking across modalities? Personally, I would like to, have a chat with everybody collecting fMRI data about physiology because I understand how much of a mess that can make. But that isn't necessarily something I have a forum or there's no really consistent way that I can talk about those concerns that I have. And I'm assuming that if I start doing EEG and MEG, and there will be things that people in those modalities would kind of like to tell me about of what I should actually really worry about when I'm trying to make these comparisons. So I guess I don't know what there is in terms of your COBIDAS and things like that for when we try to actually join up these things. So how do we share the methodology and how can we flag areas where there's still a bit of uncertainty?
Let me try and address that, because we've got a COBIDAS for MRI, and that was Tom Nichols and the committee, and that was published, a commentary was published in Nature Neuroscience in 2017. and that document is available online as well. We've just completed a document for EEG and MEG, and that's online on the Open Science Framework, and we're just writing a commentary right now for people so that they can know about it. But what hasn't happened yet is for somebody from the community to get together and co-opt a group to look at this kind of issue across modalities. And as the chair-elect of the OHBM Council, I would urge you that if you are passionate about that, to put your big toe in the water and work to that, because the community needs it. The community also drives these kinds of initiatives, and we've had 2 initiatives that have been community-driven. Hasn't come from the council; it's come from the community. So I would suggest you get involved with that. Get involved with the OHBM thing and direct one of these efforts, which I think you would do fabulously well. I knew you'd be speechless.
So I totally agree. I think we really have to put more effort in these best practices. But in the past, I've already been putting effort in best practices. We already have a paper more than 5 years ago, best practice for MEG, which also formed the basis for the COBIDAS report. And I realized that a lot of people are not following the best practice. So I think that we have to work on outreach, have more people actually be aware of what the best practice is, explain why it's so relevant, and perhaps also from the side of the journals and of the reviewers, ensure that people are following decent practices.
I'll piggyback on that and say that my experience from teaching intro to neuroimaging type classes is often that students get ideas on what best practices are by what software tutorials tend to include in them. Saying, go read this, I'm going to call it a governing document, go read this best practices document. And back in the days of Terry Picton 2000, we had a EEG paper of best practices, which arguably is very outdated at this point, was less attractive to the student who wants to punch things into a computer, hit enter, and see a pretty figure, and feel some sort of accomplishment, dopamine, and sort of that.
So that's also what I see. I see people referring to the filter pipeline, which is just one example that I have happened to put on the website, which I haven't really thought about too much. It just worked on this single subject data set that I had available that I was able to share at that moment. And I think that these are often over-interpreted or overused, whereas the best practices efforts, which really represent the wisdom of a much wider group, such as with COBIDAS, I think they're much more valuable, much more relevant. So I think we should not. I think like software tutorials are definitely useful in learning how to use a software, but not necessarily how to do your research properly.
There are troubles with having pipelines, and because we debated about that on the EEG and MEG committee about best practices, and do we put in a standard pipeline into the document? And we didn't do it because there wasn't agreement on the committee about what a standard pipeline might look like, for the simple reason that you might change the order of various steps that you execute in the pipeline, depending on the type of analysis you do. Like, to give you an example, I will do ICA on my data to identify artifacts. So I have very, very wide windows for my filters. I'm not going to filter early. I want to capture the artifact and be able to remove it. But that's not going to work for some sort of other data analysis. And so that's why we named the various steps that one would use to analyse data, but we didn't suggest an order because of these issues with different analyses. And that's, I think, the challenge for some methods like EEG and MEG, where there's so much flexibility of what you can do with the data.
Yeah. And that's also where I think that for practices to develop, we need to share more details. I think that experimental papers should really share more details. They should share the code. They should, of course, also share the data. I think it's going to be extremely valuable if in a new paper the statement is made, we did the analysis according to this previous paper. And I think that is going to establish pipelines. Like in the long run, if certain repeated applications of a certain pipeline that was introduced in one paper, if that's repeatedly successful, then that's a sign of robustness. And that's where the tutorials, they're not robust. They have not been made for robustness per se.
So on that note, I would urge everybody and everyone in this room and people who are listening online to, as reviewers, when you are reviewing a manuscript, and now I'm putting my editor's hat on, please look at the methods details and remember that this is a recipe for somebody who's interested in the science, who wants to repeat the reader might be interested in repeating the science. They have to have the details to be able to do that. And so you need to make sure that the authors provide those. And people often forget that. And I still, when I screen manuscripts all the time, and I don't see really basic things, like bandpass filters on EEG studies. No one puts in the higher cut, and there has to be a higher cut because we have to satisfy the Nyquist criterion, and that's really basic.
So that's something that could be a little bit more standardized. I agree that I think most of the best, like COBIDAS, the best practices, 90% of it was reporting, right? Because as you said, there was no agreement on how it should be done, but everybody agrees we should say how we did it. But when you review for neuroimage, for example, you have to answer 5 questions about could it be longer, could it be shorter? Why couldn't you just ask, is it COBIDAS compliant, right? Did you actually look at the document and say, did this article report everything that COBIDAS says that it should? That would be one way to nudge all of your reviewers towards more complete reporting. And that's something we could take to Shakespeare today, right?
That's very good to hear as a neuroimage editor, and there's a couple of us sitting here, because we've been reluctant to enforce that on everybody. But coming from outside, that's very encouraging to hear that.
Let me say, as someone who often reviews papers, if you're going to say, like, have a question like that, and you happen to run a major journal and have some influence over your publisher, maybe put in line-by-line questions. Did they report their filter settings? Did they report their artifact rejection settings? Because if you say, like, is this compliant with a document that's well over 50 pages, I'm going to be very grumpy as a reviewer at that journal, and even more grumpy at the authors and the editors.
So you could have yes, no, and not applicable, other. It's complicated, right? The main point is just to sort of to nudge the reviewer to think about it, right? Yeah. So I find COBIDAS is great, right? When I've been reviewing papers for a while, and I'm always annoyed that the details aren't there. But then you can ask, well, is it really? Should I be asking for this detail? But now I can just say, go look at COBIDAS and please send this back again, right? It's a wonderfully useful document.
I think the other alternative. Oh.
Sorry. Please go ahead.
The other alternative is to follow something like what Nature Neuroscience does, which requests the authors themselves to fill out and answer a bunch of questions about their method. And then the onus is on the author rather than on the reviewers, and it doesn't get sent out for review until that page and all of the questions are answered. And then I think that that's a really useful thing, because then you're not putting a huge burden on the reviewer, but you're putting it on the authors who know the data best. And so maybe that's another good option.
Yeah. Yeah, so that this also relates to what I was planning to say. Is like within the open source community, there's also efforts in making a COBIDAS checklist, which would be an online website where you basically can fill this out. So which would put the responsibility on the researcher, and you could just ask. It's like the review could ask whether the COBIDAS checklist has been followed, and that would already raise awareness.
And Peter, it wouldn't be 50 pages.
Yeah. But it's tooling, and it's tooling that has to be supported. There's people working on this, like spending serious time on this, not necessarily getting rewarded for this. This often has to happen in evening hours, because this is not what we're being funded for.
If I can go back to like my original sort of impetus for this line, In a way, I'm more concerned about acquisition than analysis. You can always reanalyze your data, but if you didn't collect the data, you never have the data. And I throw every monitoring I can at a person. They're covered in wires and cables and things, and I'm sure they love it. And I know I'm missing things. Like being at this meeting, I've been thinking about, I want eye tracking, I want galvanic skin response, I want more cables and more measurements. I'm not smart enough to know how to use them now, but I might be in the future. And so I think there were so many aspects of capturing behavior and really understanding details of how we give a task or a stimulus. And that isn't specific to a modality necessarily. It's specific to combining things all together holistically. So I don't know who, sorry, yeah?
No, after you're finished.
Well, anyway, I just think that I've suddenly become aware of more things I should think about when I'm doing my next experiment. And a lot of that is about how I collect the data as opposed to what I might do with it afterwards. So I think that's the area where I'd particularly like to see, could we take some of the guidance we have for reporting analysis and help build frameworks to get us thinking about some of those details at an even earlier stage.
So building off of that, I feel like whenever I think about do I want to collect, multimodal data, the biggest question is what do I get by doing these both at once or both in serial that I wouldn't get otherwise? And sometimes I know the answers, sometimes I don't. The format that I think would really help to answer that question is sort of a case study format. Here's someone who collected EEG, fMRI, or here's someone who added galvanic skin response, and it wasn't really useful because of that. Here's how someone was able to collect galvanic skin response and really leverage it to make it a better study. So focus a little bit less on sort of the scientific findings, and focus more on case studies of what has or hasn't worked. As I'm thinking about this would be kind of an awesome educational session at HBM if anyone wants to organize with the new extended deadline. We have like a week or something. But it feels like that case study approach is particularly suited for this multimodal because to make a document that really, it's hard enough to make a document that spans one modality, which is why these COBITUS guidelines ended up focusing more on reporting. But to span multiple modalities, it seems like my sense is the case study approach would be a lot more powerful than trying to say a best practices approach.
I guess one thing that I would add is I think there is the part of thinking of purpose. So it really does come down to what one intends to do with their analysis. And or straight from the beginning, design the experiment. Am I doing a cognitive experiment? Do I plan on just looking at the group? Do I plan on looking at individual differences? The latter takes on a whole range of challenges. I think it's a great idea to actually try to get folks to think, or what are the, at least map out the decision space that one should go through. One thing I would say is I don't really find, how do I put this? If I look at it, I've probably had 4 retest grant applications I've put in over the years. The worst, I would argue some of my best written ones, some of the worst scored I've ever gotten. Some of them are like, hey, pull together a great team. We're going to acquire a bunch of modalities, share everything over the course of 3 years. Really, and the thing is reviewers just don't want to hear it. The reviewers then basically said, well, but the measure is already being used, so who cares about this? And I've seen this time and time again. And I think some part is you'd have to make things difficult enough for people to want answers. So if it is that you had to actually explain why you're going to use measures that you're using, then you would need data to sit there and explain that. And some of that data already exists, and people could get the answer, but it's not a sexy publication. It's tedious. The answers are often not what people don't want to hear, and so they don't look. So, if you were to sit there and think of it as far as with any measure you're going to use, so there's first the data acquisition. Have you optimized your data acquisition to be able to get reasonably reliable data with some bare minimum set of measures? And then also whatever measures you're going to use, has anyone shown it to be reliable? If so, then is it distinct from other measures? So, those questions, I think, you'd be amazed how quickly I think a lot of research would get stopped, and folks would have to take a step back if they actually had to say why they're using it, why not. But that makes things more tedious. It makes for less glorious publications. And I could tell you study sections don't like it, at least the ones I go to. So I think it is this part of bringing rigor to research and changing the culture. And a lot of times if you speak to program gets it. But then it's getting killed in study sections, which is each other essentially. And then it's like back on us because then you can't convince your peers. So I think there has to be some way of kind of forcing that change. The journals, the one thing I can imagine, if you put those kind of restrictions in journals, then people will sit there and avoid some of those, unless it's a high impact journal, folks will start to avoid it. That would be the penalty the journal would pay, if I had to guess. I mean, I'm not trying to be pessimistic about it. But I do think it's a great idea, though, on the flip side, to start getting those conversations going of what's the bare minimum, what's the space you should consider, what's the range of options, and at least be able to justify per some standard why you chose what you did.
I'm just thinking about OHBM's publication platform, online publication platform called Aperture that Peter and I are involved in. And I'm wondering, given what I'm hearing from the comments here, whether it's worthwhile commissioning a set of online articles by people in the area with expertise in different areas of methodology to attack that problem, as Molly suggested, and be able to provide a resource for people who are new to the area, and that would be something that they could go to. Peter, what do you think about? I mean, I'm putting you on the spot. We haven't discussed this, but it just occurred to me now.
Yeah, we actually, we did discuss this a little bit. I mean, it's sort of a moving target as well, though, and certainly it would. So I'm actually thinking of more of a. I mean, so having best practices multimodal best practices, I think is something that. It'd be nice to sort of add, to have some sort of living document as well. I mean, there's nothing that stops Aperture from having living documents as well, sort of something that keeps on being updated. Definitely, yeah. No, I think I think that the field needs this type of information a lot more. I mean, sharing and pooling and standardizing without stifling is definitely something that needs to have more of a structure to it. And I think Aperture could do that.
And I was thinking along the lines too of just isolated techniques, like Molly was saying, okay, you don't have experience in GSR, but somebody could write a tutorial on what to do and what not to do, what are the pitfalls, what should you be doing, and sort of like a mini best practice, but based on their experience in the area, and that might be helpful when they provide all the methods details.
I'd just like to add to what you're all saying, that if we as a community embrace the new social neuroscience of live interactions between individuals, if this becomes an area that is meaningful, then it really puts an additional burden on our acquisitions, for example. It's very hard to imagine accurate a collecting of information that is happening so rapidly. We're dealing with millisecond range with data that's not acquired sequentially. It's not acquired simultaneously. And so in order to embrace this new area in neuroscience, I think we have to embrace some new techniques to acquire many modalities simultaneously, and then use our triggers across modalities to relate the databases that we have. And this is a sort of a new and developing field, and I really like your idea. I was thinking of Jove articles. Jove, that's the kind of thing you're thinking about, where one can write sort of a recipe of how you do this, that might be very useful to the field for something new of that kind.
I just keep thinking back to Bob Cox's talk yesterday, because one of his take-home points is no one in this room actually has best practices. We just have practices that were better today than they were yesterday, right? And they'll continue to grow. And it's a lot easier to think about what our worst practices are, the things that we now know as a field don't do, because there's a lot more consensus on that. Right? I mean, but you look at for someone coming into the field, right? I pull up the best practices circa 2000 fMRI, and I now know that a lot of those, I mean, I don't know if that's necessarily true, but a lot of those things that we used to think were best practices, we don't recommend anymore. And maybe that's kind of where we should think about, we still have this flexibility to expand our pipelines, but don't include these features in your pipelines, because we know as a field these are bad.
Yeah, they're living documents. That's what Peter Bandettini was saying earlier about living documents. A lot of these best practice standards are going to be revised. And I believe the fMRI Cobitus is going into 2.0 now. So that's already being updated.
Yep. I really like the idea of having a major organization that happens to have a journal keeping a list of, or sort of curating articles or curating blog posts even of best, worst, decently okay, at the moment, constantly being updated practices, because at any given time there are a series of bloggers, myself included, who, and when I started blogging on EEG and fMRI, there were about 12 of us, and now there are 2 of us. And you can just kind of see, like, they sit and age not in a good way. And so people will go and they'll find these articles because, well, we're churning out the best Googlers in the world. I mean, that is what education is doing. And people are, if they see a Google result that says, OHBM, best worst practices, don't you dare do this, or it'll never get published, prove us wrong, then that might carry a lot more weight. And it might also help keep this knowledge current instead of sort of aging out and continuing to be terrible.
Yeah, I think it's also probably useful to have something that says, here are the considerations. Best practices has this very final feeling, and I feel like considerations would be useful. And if you're going to curate, if you're the lead editor of a journal and you're going to curate some of these papers, then even having people that have differences of opinion write on the same topic, so that at least the field is aware that here are 2 perspectives, here where they agree, here where they disagree. I think that fuller story is actually useful, possibly. And going back quickly to Molly's point, I also wonder to what degree, as we're talking about multimodal imaging data collection, or not just imaging, but all kinds of data, I keep coming back to like fundamental quantum mechanics, which is that if we start measuring it, are we going to perturb the system, and then it's no longer going to be what we thought it was, particularly when we're thinking about something that's ecologically valid, and you want to do social interactions, but you have 10 things on you. I think there should be more focus too on what is it that our measurements are doing to the cognitive state, to the arousal state, to the emotional state, to everything else, before we get too carried away, or at least know ahead of time what's likely to happen.
One thing I would say is maybe one way of, well, to the first part, one thing is I personally feel like if you call it minimum requirements or minimal standards, it sets you, it does get, because this word best practices, it just beckons, first of all, the person to be like, oh, come on, and you can't just, and I've been going through this where I know with the non-human primate consortium meeting that we had a month ago, we were working on a perspective paper, and everyone's okay with the thought of identifying common practices, because we were able to say that, but no one wanted to actually say they were best. They're like, these are things that we actually do that it turns out everyone came to similar solutions. And but if you do think of it as there are minimum standards, that just figuring out what's that minimum standard will pretty much start. And then it's like, if you're not going to use the minimum standard, then say why. It's just like if, for someone who's imaging nowadays, if you're not going to image with one of the sequences that the large-scale imaging projects are using, that might be totally fine, but you should probably say why. If there's something methodologically that you think there's advantage, that's fine. But a lot of times you speak to folks, and it's just because their physicist thinks it's a good idea. And that's probably not a good reason. So I think minimum standards would help a lot. And yet, then to your other point, it is tricky with once you start putting too much on folks. I mean, the good thing is if you have it on them long enough, most people will probably stop paying attention to many of things because they can only hold a certain front for so long. But it is a challenge, and the bigger thing is the compliance will just drop immediately. And that even with that, as we put more and more burden on participants, there needs to be more and more give back for what they get from participating. And that's a significant challenge, because otherwise, if you're just, you're not paying them enough money to go and wear this or that and do all these things that we want them to do if we're just going to give them, so it really is thinking about what actually motivates them and what, there's a lot of factors from that perspective.
I'll follow up on that and say, like, certainly in clinical research, going back to, again, reading disabilities, one of the benefits that I think gets lost in certain other types of clinical research and MRI is not giving people the behavioral outcomes. So again, to stress, like, if you give someone an ADOS or you give someone a reading assessment, giving the parents that, even if it's not signed by a neuropsychologist, even if at the end of the day they can't take that to get services, they still have something that says, my child's doing well, or I have reason now to take my child to a neuropsychologist or a clinician to get an official report to get services. And one of the things that I often come back to, because obviously there's a lot of controversy with the DSM-5, there was a lot of controversy with the DSM-4, which is why we had the technical revision. Almost all of these things were created so that people could get services. And I think that one of the things that we should be aiming for, just as Mike said, is trying to make sure that the people who are coming in for clinical research who we identify as needing something, just like when we have incidental findings, can come out and say, okay, now as parents or now as an individual, I know that maybe I should go take this into account.
Yeah, I mean, that's actually, so like when I was talking about, so with NKI Rockland, when we had done that sample, what we had done in order to help recruitment is basically tell folks anything we find, we will write. We had a clinical psychologist reviewed all the findings from the study on weekends, and would sit there and we had a short form assessment report that folks were given and treatment recommendations. And that came after a significant fighting with one or two individuals who were bothered that I wanted to give the study, which to me, I mean, coming from a medical background, it seems like insane that you'd be holding this back. Now with HBN, the thing that's helping recruitment so much there is the recruitment is heavily centered around, are you worried about your child? And there we actually have built a front line of trained clinicians. And so it's not research assistants getting the diagnostic assessments, it's the clinicians, and they write extremely wrong reports, just like you would get clinically. And initially we had the abbreviated learning assessments. And what happened was then we actually went with pushback from the school system, where the school was saying, yeah, maybe you think the kid has a learning disorder, but we're not going to use this to motivate anything. So we went and increased the testing in the study to the level of what's needed for an individualized education plan. And so now participants are getting an incredible amount because the report would cost thousands of dollars to get. They're getting it free. On the flip side, you also now have a participant body who the next thing you're going to do needs to be substantial because the first thing was so big. But it does make it where they're getting a ton out of participation. And so, I mean, there's also a lot, I mean, to do something like that, basically I had to build a clinical service in the project in order to pull that off. So there are differing levels it could be done at, but I think the more it can be done, the more we will get folks to participate.
I completely agree. I don't want to shortchange anything, but we have a question in the back. Come on up.
This might be a wild question, and this will go to different direction. But I'm
Sorry, can you speak more into the microphone?
It's working. So I'm wondering if bridging monkey studies and human studies is within the scope of multimodal, and I'm wondering whether our understanding of how different neural measures converge or diverge would shed light on how we bridge monkey studies and human studies.
I would argue yes. I think there's a range of questions. First of all, you can only ask in non-human primates or neurosurgical patients. And so first of all, you do have a natural bridge, as that might sound a little strange, but between those two populations, as far as phenomena you're seeing in one versus the other. And then to the degree that, if you got overlapping data from populations that are non-human primates or from neurosurgical populations with folks who you can't go as invasive with, you'd be able to be informing among the different directions. So I think in the ideal, you have some populations that are characterized at multiple scales, you know, ranging from macro, meso to micro, and then others you're going to be more limited in what you can do, but you build the bridges enough to put the pieces together.
Along the lines of future data collection, it seems like every once in a while there's a new data collection modality that comes along from industry or something outside the research world that allows you to collect data in a new way. Is there anything that you as panelists have seen up and coming or might be anticipating that you would be very happy if it made the jump from the rest of the world to the research world? I'm thinking about transcription, facial affect analysis, app-based phenotyping, anything along those lines.
Well, along those lines, certainly Google and Yahoo have algorithms that I would die to get my hands on because they are so sophisticated with respect to facial analysis and facial classification, and would provide some of the primary information that we need for machine learning and characterizing facial expressions in the context of understanding circuitry associated with emotion and communication of emotion. So yes, I think there's some things out there that are amazing. Another example are robots. I would love to have a robot that just did what I told it to do. You know, wouldn't that be great? And so you could use the robot as a digital human and then use it to understand human responses in the social in a social situation. So I think that the development of robots is another field to keep our eye on, to watch for ways in which there could be some translation. Did you have some ideas?
Sure. I think Amazon Mechanical Turk is one that's made the jump, made a lot of interesting things possible. I think I've heard you give a talk on this. App-based EMA gives us some interesting possibilities. You can collect from the front-facing camera and maybe learn more about how what people are doing while they're collecting that data. I think eye tracking might get a lot better if we have deep learning methods doing the eye tracking. You might be able to do it remotely without, observing without touching or changing it. All kinds of interesting possibilities.
Certainly, there's also the wearable Bluetooth EEG sensors that people can, there was one that tracked your sleep cycles that went out of business and things like that.
There's 800 mobile EEG sensors that might not live to see tomorrow.
Yes.
Yeah, along those lines and thinking about reliability and individual differences, do you think there would be any value in acquiring data surrounding the time of the scanning? I mean, or should we put some constraints about when you are going to do a blood test, they ask you not to drink or eat, and when we do scanning sessions, we really don't know what happened in the 24 hours before for these people, and maybe some factors can really help explain some of the variability that might not be clinically useful and allow us to narrow the distribution curves. Any thoughts on that?
Yes, I mean, actually, so the first reliability grant I got killed on many years, actually the first R1 I tried to write, we tried looking at satiety, time of day, menstrual cycle, questions like that, which all you would imagine are relevant. You could, I know with studies, some studies will have actigraphy from the day before. That of course would be helpful for indexing sleep, but really you want to have more. I mean, ideally, having a single night's measurement from actigraphy is probably not going to do you so much good. But I think that sort of real-world measures will help. I mean, in particular, the actigraphy will help a lot in sleep diaries. And then the other part, there are opportunities to analyze an existing data set. And I've heard people talk about it. I haven't seen someone really do it, where you take some of the large-scale data sets that would have information about time of day for scanning. If you're asking about functional connectivity, I would probably think time of day is a massive factor because the way arousal ties in. And there's just so many different things pointing to the kind of that there are these fluctuations that are more reflective of microsleeps or low arousal moments or whatever one wants to call them. And I mean, it's just been a repeat theme in the literature now for years. And that's in the data. I mean, I think it was Tagliazucci in Neuron, there was a paper that took the 1,000 functional connectomes and when identified in each subject the number of TRs that looked like someone, was sleeping. And that's been done in a number of different ways. But that's in the data. And, then there could be when you start thinking of ADHD, you could ask questions about frequencies of low arousal states. I mean, there's just that, I would say, the arousal question. I mean, if there's one thing that actually has a big impact on functional connectivity patterns, we know it's arousal. So that would be the one that I would probably most chase after.
And just kind of to follow up on that question, it depends on why you're asking. Because if you're asking in the context of what measures would be really simple to add right now, we might not know how to use them, but we really want them 5 years from now in these giant databases, I think there's easy things to add. If you're asking questions like, oh, everybody should go out and buy a N-title CO2 measure because we need to account for this variability, and all of a sudden every lab that does fMRI has to spend $60,000 to buy one of these MedRad systems, I think it becomes limiting, right? I think if you had that level of, we talked about minimum standards or whatever, if you tried to impress that level of minimum standards that everyone needs to do this, you're going to basically push a lot of the lower resource junior investigators out of the field because you're going to have all those requirements. You had to have all these covariates, all of a sudden your sample sizes just grow enormously and you can never control for any of this. So it depends on how you're asking that question. If you're asking it from a, future self, this would be nice to have, but
another way to ask the question potentially is we're thinking of multimodal, so instead of adding an extra modality, would it be useful to have all these additional things collected around? It's just to add that as an extra, extra layer of information, and I think things like wearables or what they were saying, there is some technologies that may allow you to get information leading to that moment, and not just have information about those 20 minutes or 1 hour.
I think we can also turn back to the people who build our scanners and systems and say, this is a measure that's important to us. Everybody can collect the pulse because it comes with the scanner. For an extra, probably what it would cost them, $100, you could incorporate other types of monitoring like CO2, that's my thing, fine. But it isn't that expensive, but I do take your point that it's extra kit, it's extra setup. But if we can agree it's useful, I think that companies do listen to that eventually and could incorporate more easily than all of our labs trying to reinvent some of this equipment wheel. So that's another direction that we could go.
We are actually at time, so I want to roll us directly into the grand finale summary. No pressure. This is my fun, putting my boss on the spot, who was kind enough to let me run this. So let me get him set up.